Here's something that might completely change how we think about ancient fish evolution. Two newly discovered species are rewriting the textbook on early teleost development. And the evidence is so well preserved, it's almost unsettling. Dr. Martin Ebert's groundbreaking research, published in the prestigious journal Zitiliana, has unveiled two remarkable species from the enigmatic Thrissops genus that lived approximately 150 million years ago. But here's where it gets controversial. These findings challenge everything paleontologists thought they knew about ancient fish behavior and habitat preferences. The first discovery, scientifically named Thrissops ettlingensis, SP Nov, emerged from the lower marine Tithonian platen calc deposits near Ettling, Germany. The second species, Thrissops kimmeridgensis, SP Nov, was unearthed from the famous Kimmeridge clay formations in Dorset, England. What makes these discoveries absolutely fascinating is that they belong to the Teleostei group, the same evolutionary lineage that dominates today's oceans and rivers, representing an overwhelming 96% of all modern fish species. To put this in perspective for those unfamiliar with fish evolution, imagine discovering the ancient relatives of nearly every fish you've ever seen, from the goldfish in your bowl to the massive tuna in the ocean. The Teleostei lineage stretches back an incredible 250 million years to the Triassic period in China, making these creatures living links to our planet's ancient past. These newly described species belong to a particularly intriguing order called Ichthyodectiformes, which existed from the mid-Jurassic period right up to the Upper Cretaceous, essentially ruling the ancient seas for over 100 million years across every continent on Earth. What set these fish apart from their contemporaries was their distinctive anatomy, a unique tail skeleton structure, a specialized skull bone called the ethmopalatine, elongated anal fins, and notably small dorsal fins positioned unusually far back on their bodies. But here's the part most people miss, and it's absolutely mind-blowing. The German specimens of Thrissops ettlingensis include something unprecedented: the only known juvenile Thrissops fossil ever discovered. Dr. Ebert's observation raises a provocative question that challenges conventional paleontological thinking. I realized that the juveniles of Thrissops lived somewhere else, he explained, noting that other Teleostei from the Solnhofen archipelago show up to 50% juveniles in the fossil record. This discovery suggests these ancient fish had complex life cycles with distinct juvenile and adult habitats, a behavior we're only now beginning to understand. Meanwhile, the English specimens tell an even more dramatic story. Steve Etches recovered over 80 fossils of Thrissops kimmeridgensis from the Kimmeridge clay. But here's where the evidence becomes almost cinematic in its implications. Many of these specimens consist only of isolated heads and tail fins, grisly evidence of ancient predation in deep waters. Dr. Ebert paints a vivid picture of this prehistoric drama. As I imagine, the fish at the time of the Kimmeridge clay lived in deeper water, farther from the coast than the small, relatively shallow platen calc basins of the Solnhofen archipelago. There, in the open water, was probably enough food for larger predators, which also fed on the abundant Thrissops. The isolated body parts aren't random. They're evidence of a brutal ancient food chain where massive predators systematically hunted these fish. What's truly extraordinary about these discoveries goes beyond their evolutionary significance. Some of the German specimens are so exceptionally preserved that they still contain their final meals and original color patterns. Two Thrissops ettlingensis fossils had Orthogoniclethorus hoeli fish still intact in their stomachs, with vertebrae so perfectly connected that researchers could determine these fish had been consumed just moments before death struck. Even more remarkably, the color patterns remain visible on several specimens, showing dark melanin pigmentation in the center of individual scales. This level of preservation is so rare, it borders on miraculous, offering us a window into the actual appearance of creatures that lived when dinosaurs ruled the land. Interestingly, both species share the fundamental characteristics of their group: compact heads, single-rowed teeth, deeply forked tail fins, rear-positioned fins, and those distinctive ethmopalatine bones. However, they notably lack the elongated body shape and broad, saber-like first rays in the pectoral and pelvic fins that define most other Thrissops species. This variation suggests the genus was far more diverse than previously imagined. The implications of these discoveries extend far beyond simple species identification. They provide crucial insights into early Teleostei evolution, revealing details about morphological diversity, dietary habits, and even prehistoric color patterns that were previously impossible to study. And this is the part most people miss. Dr. Ebert's research represents just the beginning of a much larger investigation. His database now contains over 23,000 fish specimens from approximately 100 collections, all meticulously catalogued and updated with current taxonomic names. This massive undertaking is revealing patterns about where certain genera were common or looking toward the future. Dr. Ebert plans to develop phylogenetic studies that will incorporate these new species when he tackles the related genus Thrissops in the coming years. However, his passion clearly lies in understanding the broader ecological picture. "I'm even more interested in the diverse ecology of the Upper Jurassic sites," he explains. "There are sites where certain genera are common or rare, which also applies to the genus Thrissops. And that tells us a lot. But here's where it gets controversial. Do these findings suggest that our understanding of ancient marine ecosystems has been fundamentally flawed? The evidence of distinct juvenile habitats, systematic predation patterns, and preserved color schemes challenges many assumptions paleontologists have held for decades. These discoveries force us to confront a provocative question. If we've been wrong about something as basic as where juvenile Thrissops lived, what else might we be missing about ancient life? The isolated body parts from the Kimmeridge clay paint a picture of prehistoric oceans that were far more dynamic and brutal than many textbooks suggest. What do you think? Does this evidence of complex juvenile habitat preferences and systematic predation suggest that ancient marine ecosystems were more sophisticated than we've given them credit for? Or are we reading too much into incomplete fossil evidence? The debate continues. And your perspective matters in shaping how we interpret these remarkable windows into our planet's distant past.